All right, PIPFA public sector and DO exam students, let's jump right in. If you've been staring at construction contracts, totally confused about how we actually calculate cost changes when market prices go crazy, you're exactly where you need to be. Today's explainer is going to demystify the exact mechanics of the PEC 2022 standard procedure for price adjustment. We're going to take what looks like a super dense mathematical maze and turn it into a clear, logical, step-by-step process. By the end of this, you'll be tackling these questions on your exams with absolute confidence.
This document right here is our holy grail for today. It's the official May 2022 second edition from the Pakistan Engineering Council. For literally any public sector infrastructure project in Pakistan, this is your ultimate source of truth. It standardizes exactly how we adjust contracts when prices for materials, labor, or fuel inevitably jump around. It basically ensures the contractor doesn't go bankrupt from inflation while also protecting the employer from paying totally unverified price hikes.
To really master this, we're going to break it down into 4 logical pieces. First, the 3% rule. Second, representative elements. Third, the 75 and 25% weightage caps. And finally, unpacking that famous adjustment formula itself.
Starting right off with step 1, the 3% rule.
This rule is the very first threshold. It's the strict gatekeeper for any price adjustment. Here is a massive tip for your exams, so definitely lock this into your memory. For an element to even be considered for an adjustment, its cost impact has to be 3% or higher of the total estimated contract cost. Just think about it practically for a second. A massive highway project uses thousands of individual items, right down to the literal screws and paintbrushes. If we adjusted the price for every single tiny item, the administrative nightmare would cost way more than the materials themselves. So the 3% rule ensures we only focus on the heavy hitters.
So how do we actually find that 3% in practice? Well, we follow a super clear 3-step recipe. First, you pull together the overall engineer's estimate for the entire project. Second, you run an appropriate rate analysis to extract the costs of the basic elements. You're just taking the base market price here, deliberately excluding any overheads, profit, or installation costs. Finally, you divide that specific element's cost by your total engineer's estimate. If that resulting decimal is 0.03 or higher, boom, that element is officially on the board.
Moving on to step 2, using representative elements.
Now that we know what qualifies, we really need to simplify the math so we aren't just drowning in variations. And the PP procedure is brilliant at preventing us from overcomplicating things. Instead of painfully tracking the individual market fluctuations for every single type of steel on a site, sheet steel, grade 60, grade 40, we just group their base prices together. Then we use one single proxy, like grade 40 half-inch diameter steel, to represent that entire steel family's cost impact. You just track the price of that one representative element and apply its movement to the whole category.
And we apply that exact same concept to labor. Think about it. You've got specialized technicians, heavy machinery operators, basic site workers. Trying to track the wage fluctuation of every individual trade is practically impossible. So we just use the rate for unskilled labor as the representative cost element for all varying types of labor on the project. It creates a nice standardized benchmark that makes the final mathematical formula actually usable.
All right, step 3, weightage caps, specifically the 75% and 25% limits.
So here is where the limits kick in. The adjustable portion of the contract, which includes all your materials, labor, and fuel combined, cannot ever exceed 75% of the total contract value. Conversely, this means the fixed, non-adjustable portion, which we represent with the letter A, must always be at least 25%. This locked-in 25% slice represents the contractor's overhead, profit, and all those minor elements that just didn't survive our 3% rule earlier. It firmly shields the employer from bearing 100% of the market risk.
Listen up, because this right here is a classic trap to avoid on your exam. Let's say you add up all your qualifying elements, cement, steel, fuel, labor, and they total 82%. Well, you're over the 75% cap. The rules state you have to drop the lowest weightage elements one by one until you fall back under 75%. But, and this is a massive but, you can literally never exclude high-speed diesel or labor. It does not matter how low their weightage is, fuel and labor are fundamentally volatile, so they are always protected.
Which brings us to step 4, the adjustment formula itself.
We've got our elements, we've applied our caps, so let's look at the main event, the generalized formula. Pn equals A plus B times Ln over Lo plus C times Mn over Mo, and so on. I know. At first glance, this just looks like a bowl of alphabet soup. But stick with me, because based on exactly what we just covered, this makes perfect logical sense. Let's break down the anatomy of what each of these variables actually does. First up is PAN. This is simply our ultimate output. It's the price adjustment factor. Once we solve all that math on the right side of the equation, we're going to get a decimal, say 1.05. We then multiply that specific factor against the payable amount for the work done in that billing period. So, if the contractor did 1 million rupees of work and the factor is 1.05, they get a 50,000 rupee adjustment for that specific month's bill. Make sense?
Next up is A. Remember our donut chart and that 25% minimum? That's A. It's your locked-in constant, representing the minimum 25% of the contract that is completely shielded from any price adjustments. In your calculation, A is going to be a flat number, typically 0.25, firmly grounding the whole equation. Then we have the lowercase letters, B, C, D, and so forth. These are your coefficients. Remember back in step 1 where we divided the cost of our element by the total engineer's estimate? That resulting decimal, like 0.15 for steel or 0.10 for cement, is exactly what B and C are. They are the specific, fixed weightages of your representative elements calculated at the very start of the project and nicely rounded to 2 decimals.
Finally, we have the fractions inside the parentheses. These track the actual market shifts. The O stands for the base date price, and the N stands for the current date price. The PEC is strict about timelines here too. Low is the base price locked in exactly 28 days before the bids were submitted. LEN is the current market price exactly 28 days before the current payment certificate period ends. By simply dividing the current price by the base price, we perfectly capture the exact percentage of inflation or deflation for that specific material in that specific month.
Now for the most satisfying mathematical rule of this whole explainer. It's also the ultimate way to check your work on an exam. The sum of the fixed portion, A, plus all of your adjustable coefficients, B, C, D, whatever you have, must perfectly equal 1.0. If your fixed portion A is 0.25, then your material and labor weightages must add up to exactly 0.75. It represents the entire 100% pie of the contract value.
So, as you hit the books tonight, I want you to really chew on this scenario to test your understanding. Imagine a contract where the steel weightage lands at exactly 2.8%, and your total adjustable elements add up to 78%. Before you even touch that formula, how do you fix it? Does steel get booted by the 3% rule? And if it is dropped, do the remaining elements still bust the 75% cap? Figuring out how these interconnected rules dance together is exactly what separates rote memorization from actual mastery. Work through that tonight, study hard, and I'll catch you in the next explainer.